You are welcome to GMAETS 41's channel. In this live stream class, I have a question that I would want us to deal with. Before we move on into this question, I want to believe if you're following up with GMAETS 41's classes, uploads, updates, you would have received an update of a lecture that you were required to take regarding our class on Physics 102, that is General Physics 2. Because today, this week, GMAETS 41 is dealing with the concept of optics. Right, let's say part 3 of optics, where we study lenses. So I want to believe that you've done justice to that. And as you join this class, I have this wonderful question I would like us to solve. Okay? So you join this class, I have this wonderful question I want us to solve. You have this question here on the board. But to start, I want to ask you this first, okay? Do you really understand the concept of lens parameters? Lens parameters. In the study of lenses, we have two major types of lens. From it, we now have other types that are used in microscope and telescope. But the two major types of lenses that we have, which we refer to as laboratory lens or lenses, are the convex and concave lens. Convex and concave lens. Okay, we have the plano-convex, the plano-concave, the convexo-concave, and the concavo-convex lens. But our focus in this class, and of course, when we deal with the concept of lenses, we focus more on biconcave and biconvex. Okay? So what I really want us to achieve is to see if we really have good understanding of lens parameter, especially when talking about focal length. Because when you are dealing with lenses, especially if you want to use lens formula, okay, the concept of focal length is very important. Then you now talk about object distance and image distance. You are welcome to the class. You're welcome to the class. If you join the class, give this class a like, okay? Hit the like button. You can share it to your friends, please. See this question? How about I tell you that in whichever school you are, that your examiner is going to give you a question like this. Your examiner will give you a question like this to solve under lens. So before we move on into this problem we have on the board, because it's a technical question, yes. In fact, we are going to go out a bit from physics to be able to analyze this question. But before we handle this problem, like I said, let us mention the lens parameters first. We have 5 lens parameters. Today, this morning from our end here in Nigeria, I've already listed that we have those 5 parameters. And scholars are expected to, state and define the 5 lens parameters. And these parameters include 1, the principal axis. 2, the optical center of the lens. 3, the principal focus of the lens. 4, the focal length of the lens, and then 5, power of the lens. If you actually took that lecture, all right, I actually dropped information about it through the GMAETS 41's community. I've told you this channel, if you go to the home page, you will see view community. Tap on it. If you tap on it, it will take you to the community section of this channel where you can interact with me, interact with any other student. Yeah, you can do that. For my update, you can always click, or to find new updates in the community, you can click on new or newest. Yeah, something like that is the newest. So you would see the newest updates in the community section. So if you're following up with GMAETS 41, like I said, it's very important. If you have not subscribed yet, please subscribe. It's for your own good. Remember, like I said, this is a full online school. If you want to join us fully, you join the channel on platinum or diamond level. And once you join any of those levels, I'm giving the opportunity now, both those that joined on platinum level, both platinum and diamond level, if you join any of those levels, send a message to GMAETS 41 on WhatsApp. There is the contact. Okay? If you join either the platinum level or the diamond level. Now, after you subscribe, subscription is free. Yeah, subscription is free. To join platinum or diamond level, there is a monthly package for it, monthly affordable payment for it. Okay. Now let's leave that of joining first. Per se, I want to talk about your subscription. Subscription is free. After you subscribe, turn on the notification bell. Turning on notification bell is also free. Some of you are scared of subscribing and turning on your notification bell because you think that something will be deducted from your bank account or whatsoever. No, nothing like that, please. Take note of that. Now, if you subscribe and then click on the notification bell, once the notification bell brings out the drop-down menu, select all. This is the reason. Anytime I come on live or I upload any content, you will be personally notified by YouTube. Just like this class now I'm having. I didn't schedule it. I just came up to talk about it. HSONA, you are welcome. You're welcome. Is that okay? Now look at this one, Yash. Now this is some good life where someone is actually teaching something rather than talking, unnecessary talking and doing shit stuff. Now this is some good life where someone is actually doing teaching. Okay, I don't really think I understand your write-up fully. You see, it's always important. They say if you are not informed, you will be deformed. One of the basics of succeeding in life is to be informed. I'll keep telling you guys that are following me up on this channel so that your way of reasoning and the way you handle problems, whether academically and even in life, will be unique and well defined. So I've told you about subscription and what is it called? Turning on notification bell, so you wouldn't miss out on any updates. Because by now, as I appeared live, now it is expected that you should have taken that lecture, whose information I dropped this morning on length, full lecture video on it. Now, let us deal with this. First of all, we'd have to read this question. Let's read it together and see. The coordinates of the optical center and the principal focus of a convex lens are 5,2 and 15,12 respectively. If the lens forms an image for an object placed 8 centimeters from the lens, what is the position of the image? So we're going to solve this question, get the position of the image. We'll also go further to talk about the nature of the image. Yes, the nature, which has to do with whether the image is erect, whether it is inverted, whether the image is magnified or diminished, whether the image is real or virtual. Okay? Now, we were given the coordinate of the optical center. We were given the coordinate of the principal focus. Most times, the type of problem that you friends are used to is that which they will give you the value of the focal length, they give you the value of either the object position or distance, as the case might be, or the image position or distance. What if your examiner decides to say, no, we are not going to present the question in this format. Let's give the problem using the concept of coordinates. What would you do? Just like you have this question here on the board. So this is where it calls for you, friends, understanding the key focus of what our lens parameters, are all about. For example, when you talk about principal axis of a lens, in one word, you should know that the principal axis is just a line. A line in one word. I don't want to talk too much. Line. That is what your principal axis is. If you don't want to speak further grammar in defining it, in full, properly, then you now talk about a line that passes through, the optical center. Connecting the optical center and the principal focus. So it passes through the optical center straight. If any ray of light goes through the direction, follows the path of the principal axis, that ray of light will not bend. So what should you know about principal axis? Like I said, just in one word, line. That is what optical center, principal axis is. Now let us talk about optical center. Optical center. In one word, what is optical center? Please, you guys should make sure you follow along. Follow along. What we are doing here is for your good. Are you following? Optical center of a lens. What is it? In one word. I'm not interested in the full definition. All those definitions I gave them already, in that lecture video I asked you to take this morning. Optical center is a point. So in one word, point. Again, point. That is what optical center is. We are coming to this. We are driving towards this question for you to understand why we shall approach this question the way I will solve it, which of course is the only way you solve the problem. So I've told you what optical center is. It is actually the center of the lens. Any ray that passes through that optical center will not refract, will not bend, will not deviate. It will not. Okay, now we are done with optical center. The next one I want us to talk about is the principal focus. Principal focus of a lens. What is it? In one word. Answer. Point. Principal focus of a lens is simply a word, point. Further grammar can be added up to define it fully, but just know what that parameter really is. It is a point. The question that is point on what? So we can now define. Principal focus is a point on the principal axis of a lens where rays of light appears to converge. If you are talking about converging lens, that is convex lens, or appears to diverge if you are talking about concave lens or diverging lens. So once again, what do I want you to take note of? Yash, what did you say there? Yash, okay. I may not be good in English, but can you please demonstrate what you are trying to do here? All right, this is physics class, actually, physics class, and we are dealing with lenses. Okay, we want to solve this question. This is a unique question quite different from what most of you might have known, seen, or been taught about lenses. All right, so network seems to be hanging. I don't know, please. This network should be calm. This network should be calm. So, like I said, principal focus is a point. Is a point. No wonder in this question, look at what your examiner did. The examiner gave coordinates. The examiner gave what? Coordinates. Coordinate of the optical center. Why can an examiner do this? Why? An examiner giving you coordinates in lens problem. Because like I said, optical center is a point. And a point is usually located using what? Coordinates on the Cartesian plane. I also told you that the principal focus of a lens is a point. Principal focus is what? A point. No wonder the examiner also gave what? Coordinates. And here your knowledge of math comes in. Coordinate geometry. Coordinate geometry. You have to, invite that knowledge. You have to invoke it to this problem. And I will tell you again the reason. Let's move on. I have mentioned the optical center. I've mentioned the principal axis. I've mentioned the principal focus. Now let us talk about the focal length. What is focal length? In one word. In one word. Once you understand this for what they are, the definition becomes simple and straightforward to learn and understand. So in one word, what is focal length? Like the name goes, focal length is simply distance. When you talk about length, length is distance between 2 points. So in one word, focal length is simply distance. Take note of that. The question then is distance between what? If you take lectures on lenses, you will find out that focal length is the distance between the optical center and the principal focus. The length between what? Optical center and principal focus. That is what we refer to as focal length. Which simply means, for this lens you are seeing, convex lens, focal length is the distance from optical center to the principal focus. The distance, the length. No wonder your examiner could wake up and give you a problem like this with their coordinates. I put it to you, most of us have not seen a question like this before. But this is a possible question you can be asked anytime by any examiner. Having explained this, it means that we can calculate our focal length from these coordinates. We can calculate our focal length from these coordinates, knowing that focal length is simply length or simply distance. It is distance between 2 points. And at this point, the brain is not activated. You see how we've sent out the network of our brain to bring information for us so we can be able to analyze this question. Tomorrow in the evening, I am going to tomorrow is Saturday, evening by say 8 p.m. Nigerian time. 8 p.m. Nigerian time. So if you are not in Nigeria, you can check it out, the corresponding time at your end. So you join. There is something I want to teach and explain to you people, to guide you so as to be able to help you analyze problems. I'm going to explain to you a principle called the zone of proximal development. I have found out that so many people make this mistake whenever they study. What could help them to remember and understand what they have studied? That tomorrow you are going to learn of the disadvantage of exercise question also, or of the disadvantage of going through an example first without your testing that example given to you, and then you start consulting questions from only God knows the source. So I really want to coach you friends on this to assist you to improve your level of understanding and to help you learn and understand what you are studying faster. Keep a date with me, like I said, tomorrow Saturday by 8 p.m. I've been able to expose the trick in this question. We are going to use this coordinate and this coordinate to calculate the focal length, which is the distance between 2 points. And what are the points? optical center and the principal focus. We are moving on. So I'm going to write solution now. The problem with this question, I have exposed it. Get your focal length from the optical center and principal focus by using the distance between 2 point formula. So I'm going to write focal length, which I'm going to use f is equal to square root x2 minus x1 all squared plus y2 minus y1 all squared. If you have taken lectures on coordinate geometry, which I've trashed that also on this channel online, right? If you go to the live section, you see lecture videos on coordinate geometry, or make use of the playlist. Search for Mat 101/Mat 102, you would see what's on coordinate geometry. In our physical tutorial in Unizik for GMAETS, I've also taught that. The distance between 2 points has this formula. And like I told you, the focal length is the distance between the optical center and the principal focus. So we shall use this formula to calculate the focal length. Have you seen a formula like this for focal length before? So you can see the funny and crazy thing happening in this question. But you can do this. You can do it. Always make sure you tune in to GMAETS 41. I will help you. I will really help you. I'll guide and coach you in your studies. Okay? Just pray that our God and helper, Jehovah, continues to sustain and give us the strength to do the work. And you too, you have to continue to follow up and study. Very important. So the focal length now, f is equal to, let's substitute. If you come to this question, this is our x1, this is y1, this is x2, this is y2, according to coordinate geometry. Coordinate of 2 points. So I will substitute here. The formula will now give us x2 is 15. So that's going to be 15 minus 5. You square it plus, y2 is 12 and y1 is 2. So it's going to be 12 minus 2. You square it. And this is going to give us square root. We don't have time. 15 minus 5 is 10. 10 square, we give you 100. Okay? We give you 100. Then 12 minus 2 will give you 10. 10 square will give you 100. 100 plus 100 will give you 200. So this is square root of 200. Square root of 200. And with this, you can find the square root of 200, which is 10 root 2. If you evaluate 10 root 2, what would you get? If you evaluate 10 root 2, what would you get? Let us see. Let's evaluate it and see. 10 root 2. Or simply square root of 200. This gives 14.14, I am going to use an approximate value. This is approximately 14 centimeter. 14. Please take these values. The unit should be in cm, in centimeter, okay? So that our focal length will now be 14 centimeter approximately. Now we have obtained our focal length from this coordinate. So you see, whenever you are giving coordinate of optical center, coordinate of principal focus, examiner can ask you to even find power of the lens. Examiner can ask you to find what I said, power of the lens. And you know that power of lens is 1 over the focal length. So you quickly use the coordinates of the optical center and principal focus to find focal length, and then from there. So you see, it is not all about just solving this question, rush. No. At GMAETS, there's a way I do my things. Time to rush is there. Time not to rush is there. If you go through our YouTube short, you see I blast things fast. 2 minutes, 3 minutes, I'm done with a particular question. But this is a unique and well-applied question. So I want to guide you to understand how you can make use of knowledge of other courses, subjects, to help you out in certain other subjects. So as a science student, a student taking STEM courses, science, technology, engineering, mathematics, you don't joke with all these basic subjects. You don't joke with all these science subjects. They are highly interrelated. Okay, they are connected. And maths is key. Take notes. Okay, so I have gotten my focal length. Let's now move on. We are told that if the lens forms an image for an object placed 8 centimeters from the lens, so we know the object distance. Object distance U is equal to 8 centimeters from the lens. Now we are now asked to find what is the position of the image. Position of the image, also known as image distance, we do not know. So dear friends, you see, the major problem with this question is your understanding that your focal length is obtained from this coordinate. That's just the thing. The rest now follow up, things you can play with. If you had taken that lecture on lengths, which I posted information about it with a link through this channel's community. Always follow through. Make use of the community for updates, okay? All right, so we are looking for the image distance or image position. We don't know. But which type of lens is this? This is a convex lens. Don't be too quick to start applying lens formula 1 over f equal to 1 over u plus 1 over v to solve problems, especially for convex lens problem. Don't be too quick. Don't be too quick. Concave lens, because of the one-dimensional pattern of the image formed in concave lens, you can quickly apply that formula 1 over f equal to 1 over u plus 1 over v, and then know that your f must be negative or your v must be negative, as the case might be. If you are giving f value, you must put negative to that f value. If you are giving v value, you must put negative to it. That is for concave lens. For convex lens, you don't do that. There are things you ought to know about convex lens, which in that lecture I asked you to take, I have covered all of them. I talked about convex lens forming real images in almost all cases except in one case. And that exceptional case is very important that a student give attention to when you are studying. Convex lens, converging lens generally form real image, real and inverted image. But there is a special case where convex lens will now behave a little like concave, where it is going to form virtual image and upright image or erect image. But in this question, we are not told anything about that. What will now guide us to know what to do here? We are going to compare the object position with the focal length. What is the focal length? 14 cm. 14 cm. And the object distance is 8 centimeters. So let me sketch something for you to see quickly. It's there also in that lecture video I asked you guys to take. Let us assume that this is the convex lens, and then you have your principal axis go this way. On the principal axis, you have your focal length here, Then here is the optical center C. The distance from here to here is your focal length F. Now F is 14. F is 14 centimeters from here to here. And then you observe that the object distance is 8 centimeters. If F is 14, which is from the optical center to the principal focus, if it is 14 centimeters, and then object distance is 8 centimeters, it means that the object is between F and C. The object is between the principal focus and the optical center of the lens. Look at it. U, which is the object distance, is less than F, which is the focal length. For such situation, when you are dealing with convex lens, you want to be careful, because for an object placed between the optical center and the principal focus, which means that the object distance is less than the focal length, the behavior of convex lens will change completely from the most general thing we know about convex lens. Like in this case, the convex lens will form a virtual image, will form an upright, also known as erect image in this arrangement, because U is less than what? F. Is that okay? H is on Chuku favor. Please, what did you say is gonna happen tomorrow by 8 p.m.? All right, tomorrow by 8 p.m. I want to coach you friends. It's a kind of a guideline. All right, I want to coach you on a principle known as the zone of proximal development. this particular time of life, I had found out that many people are not making, many scholars, they are not making use of the strength that comes from applying the zone of proximal development to studies. And that is why most, okay, let me not say most, some students will tell you they studied something they don't understand. Especially when it comes to calculation problems, that they studied this, they want to solve a question from there, they don't know how to apply that thing to the problem. So I want to coach you on how to read and understand what you should do, especially when you're handling calculation courses. When you study, what you ought to do. Okay, we are moving on. And of course, what you need to avoid. And when you apply that, you notice that you'll be doing very well in your studies. Let's wipe this now. I have explained the implication of this. I will use mathematical representation now. I'm going to write something here. Note, U is less than F. U is less than F. So, image will be virtual and erect. Virtual and what? Erect. Image will be virtual and what? Erect. So if you solve this problem, what you are going to get, the final result you are going to get, supposedly the image position V is expected to be negative. Is expected to be negative because of what happened there. In fact, if we had been given the image position, assuming in this question they gave us the image position and they asked us to find maybe the focal length or the object position, okay, they give us, let's assume, image position V, the value was given, and then they say you should find the object position. Because of this situation, look at this case, look at this thing, because it's only in one case that this thing occurs, when you are talking about position of an object and the image formed with respect to convex lens. If in the question we are given the image distance, because of this singular fact, when we are substituting into lens formula, that image distance will carry minus if the value of the image was given. But although here we are looking for image distance, and I'm telling you, because of this singular fact, the final result we'll get for image distance will be negative. Because this image is going to be virtual and erect. How did I know even without solving the question? Because of this singular fact that object position is less than the focal length. With that alone, I have gotten to know the nature of the image. It's just to now maybe solve and get the magnification, whether it is diminished or magnified. Okay, I think I've analyzed all these things. We can now solve. Applying 1 over f, your length formula. There's a lot of information you have gotten from this live class, even if you are dealing with just one question. 1 over u plus 1 over v. This is the formula. Let us now substitute. 1 over f, our f is 14. 1 over u, our u is what? 8. Okay, 8. And then plus 1 over v. So let us work on this quickly. So no space here. I want to maximize the space. I want to solve everything here. So you work out LCM of this. What is the LCM of 14 and 8? Just since 8 cannot divide 14 completely, but they have the highest common factor. I think 2 is the highest common factor there. Multiply 8 by 14 and then divide it by highest common factor 2. So as to get, you know, your LCM. 8 times 14 is going to give us what? 8 times 4 is 32. 2 carry 3. Then 8 times 1 is 8 plus the 3, 11. So it's going to be 112. If you multiply 14 by this, you get 112. Divide that 112 by 2, which is the highest common factor of these two guys. So 112 divided by 2, the highest common factor of 14 and 8. What are you going to get? You get 56. If I'm not wrong, 2 here, 5 times remainder 1. Good. You get 56. So the LCM here is 56. Let me move this guy to the left even before we do that. Permit me to fix equal to. If this guy crosses here, LCM is 56, like I said. LCM is 56, like I said. So you have 56. 56 divided by 14. What are you going to get? 56 over 14, you can work it out. We don't have time. Let me just press my calculator. 56 divided by 14. But you can always reduce. Nothing is there. Okay, 7. You can reduce. If you're talking about this, 7 here will give you 8. 7 into 14 will give you 2. Then 2 can divide 8 to get 4. So, of course, 56 divided by 14 is 4. 4 times 1 will give you 4. 4 times 1 will give you 4. Then, remember 1 over 8 moved to the left-hand side. It's going to be minus. Minus 56 divided by 8 will give you 7. 7 times 1 will give you 7. So you observe that this gave us minus 3 over what? 56. So the image position is minus, let's divide this and see. 3 divided by 56, and then we get 0.05 minus 0.05. Minus 0.05 centimeter. This is the image position. So you observe how that minus came up naturally on its own. Look at it. The minus came up naturally from the solution. So the image position here is going to be 0.05 centimeter. And it is going to be on the same side. It is going to be on the same side as the object. It is going to be on the same side as the what? Object. Okay, so I think we are done with this. The position of the image position is this value you have here. Minus 0.05. And what is the nature of the image? The image is virtual because of this minus. What other nature of the image do we have? The image is erect. That is upright, standing as I am like this. It's not inverted. It's erect. Erect also means upright. We can talk about the magnification of the image. We can talk about the magnification of the word image. And of course, magnification, you know how to evaluate it. The magnification is going to be image distance divided by object distance. So this is how you solve this problem, and I hope you've learned something from it. Focal length is 14 approximately as calculated. And then we have 1 over u. The u is 8 centimeter. We have 1 over v. So move this thing here. Find the LCM, which gave us this. 56 divided by 14 is 4. 4 times this. Then 56 divided by 8 is 7. 7 times 1. Of course, this is minus because we moved 1 over 8 to the left-hand side. Equal to 1 over v. Oh no. This thing is not what we are meant to get. I'm wondering even, why will this be 0.05 or something? Because I'm expecting the image position to be greater than the object position. That's what this thing is meant to be. Sorry, please. There is an error here. Let me show you. Remember, what we are solving here is 1 over v. So 1 over v, 1 over 14 minus 1 over 8 is equal to 1 over v. I didn't indicate it. So this is 1 over v. I don't want to go to this side of the board. I want to finish everything here. I hope it has not cut off. So, sorry for that error here. Please watch once again. 1 over 14 minus 1 over 8 will be equal to 1 over v. So if you solve that LCM part, 1 over 14 minus 1 over 8, you will get this. If you simplify this, you will get this. So make this minus 3 over 56 equal to 1 over v. Because that's what 1 over 14 minus 1 over 8 is equal to 1 over v. So let us conclude. To get our v here now, can I manage this space? Because to get your v, you have to inverse. Just take v up and bring this 3 down. Take 56 up. So I can conclude that. How will I do that? Should I take it up here? I think I'm going to do so. And then I'll enclose this gauge. Always use your IQ to. I don't want to use the other side of the board. So use our IQ to work out something. So from here now, our V will now be equal to minus 56 over 3, which is equal to, divide 56 by 3, and then let's see, 3 can go into 5 how many times? Just once, remainder 2. Attach the 2 to 6, you get 26. 3 can go into 26 how many times? I guess 8 times is 24. So let's say 8 times. Remember, this result has minus. It has minus. Good. 8 times remainder 1. Put your point, attach 0 to the 1, you get 10. Divide 10 by 3. So this is going to be 3 something. Let us approximate. 56 divided by 3 will give you 18.333. Can confirm it with your calculator. 56 divided by 3. 56 over 3. See? Okay, that's 18.666. 18.666, not 3. And that's correct because 56 divided by 3. 3 can go into 5 once, remainder 2. Attach the 2 to 6, you get 26. 3 can go into 26. 8 times remainder 2. So attach 0 to 2 to that 2, divide it by 3. If you attach 0 to 2, you get 20. 20 over 2 will give you 6. Are you following? 20 over 3 is 6 times, which is 18. 6 times. Remember 2 again. Attach 0 to the 2, divide by 3. You go 6 times again. Remember 2. Attach 0 to the 2, you get 20, divide by 3. So 6. We can approximate this to 19. We can approximate it to 19. But you can use your calculator straight on. Minus 19 centimeter. That's good. Therefore, V is equal to minus 19 cm. That's the answer to this question. I thought that's more, not 0 point something. So, back to it. We have obtained what I want us to get. So, the image position is 19 centimeter on the same side as the object. Let us assume that this is your lens. Let us assume that this is your lens. And then we say the object is here. Let's say the object is here. Remember, the object is between the optical center. The object is between the optical center and the principal focus. So if this is the object, now the image, which is 19 centimeter, will be formed behind the object. This is your image. To be formed behind the object, it will be upright like this. The way the object is standing, that's the way the image will stand. It won't turn upside down. It won't be inverted, like what we really know about convex lens. It won't follow it. It won't. Because the image you obtain from here is negative, showing that the image is virtual. And because of the placement of the object between the optical center and the principal focus, the object distance is less than the focal length. Therefore, we expect that it is a virtual image that is going to be found. That image will be erect, also known as upright. And that image would be on the same side, that is in front of the lens, but behind the object. The object is there, the image will go behind it. So that is everything about this particular question. I hope you enjoyed the whole analysis. You can still replay the video at the end of this class. You know, always after GMAT 41's live class, a copy of the video is made available so you can come back to it. Watch it and follow up with all of my explanation. You will love this. And then if you have not taken that lecture video, you can make sure you take it. Go to view channel. On the home page of this channel, click on view channel. If you click on view community rather, on the home page of this channel, click on view community to take you to the GMAT 41's community. Like I said, that is a space where you can interact with GMAT 41 with other students, you know, other scholars, just like you have your WhatsApp. Just like you have WhatsApp group. YouTube have, you know, launched that and they've rolled it out to our wonderful channel. Yes, a wonderful channel because of you friends. Okay, yeah, because of you friends. So I really thank you subscribers and channel members. GMAT 41 appreciates you guys, you know. Thank you for supporting this channel and I hope that I am not disappointing. So take that lecture, if you go through the view channel, you would see the link where I posted the announcement. Tomorrow, I am going to post another announcement there, because we are going to take maths tomorrow, and we'll be teaching the concept of conic section. So the lecture video link will be made available through the view channel, so that you go there, you click on it to take you to, conic section stuff. But like I have always said, you can also make use of the playlist. Okay, let's conclude with magnification. Magnification. In this case, because of this singular fact that the object distance is less than the focal length, and the lens here is convex, the image will be bigger than the object. So for this problem, the image is magnified. The image is what? Magnified. So let us summarize. The position of the image is 19 centimeter. This minus shows two things. Number one, that the image is virtual, which means it is not real. Number two, the image is on the same side as the object. The image is on the same side as what? The object. Okay, so we have gotten the image position 19 centimeter on the same side as the object. Now, what about the nature? The nature, the image is virtual, it's not real. Why? Because of this minus. Then, in terms of whether the image is erect or inverted, the image is erect. Generally, convex lens forms inverted image. But because of this singular factors, I always point you back, direct you back to this U less than F for this question. Because of the fact that the object distance is less than the focal length, it means that the image will be upright, erect. It will not be inverted, as we know about this, about a convex lens. Then, conclusively, is the image magnified or diminished? You don't even need to go through getting magnification before you will know whether the image is magnified or not. This singular fact would also tell you that the image is magnified if you had taken that lecture video, okay, for convex lens. But what's come to us, you can calculate magnification, which is very simple. Magnification is image quantity divided by object quantity. And what do I mean by that? Image height over object height. Image position over object position. Image size over object size. Image distance over object distance. Image length over object length. You meet that one in the case of pinhole camera when you study reflection. Remember, this one is refraction. There is this magnification formula we meet in pinhole analysis. Don't worry, we'll deal with that also. Are you following, right? Which has to do with length of the image from the pinhole divided by length of the object from the pinhole. So just generally know that magnification is image quantity over object quantity. Now, why did we say that this image will be magnified? If you want to go through mathematical analysis, our image is 19. Our object is what? 8. So magnification will be V over U. 19 over 8 will give us 2 point something. Yeah, 8 can go into 19 2 times, which is 16, remainder 3. So 2 point, attach 0 to the 3, you get 30. 8 can go into 30, how many times? 3 times, which will give you 24, 3 times remainder 6. Attach 0 to the 6, divide by 8 again, okay? But you can use calculator to even work out that. So 2.3 something. Okay, let us approximate a whole number. 2 is the magnification. And now, when you calculate magnification and the value you got is greater than 1, if your magnification is greater than 1, it means that the image is magnified. The image is bigger than the object. But if magnification is less than 1, it may be 0 point something. It means that the image is smaller than the object, which means the object is bigger. In that case, we can say the nature in terms of the size of the object image will be diminished when your magnification is less than 1. What about when your magnification is equal to 1 exactly? It means that the image and the object are of the same size. So it's wonderful with you friends tonight, and I hope you've learned something. Share the link to this live class to your friends. Are you following, right? Encourage them to tune into this channel, subscribe, turn on the notification bell. All right, you can support this channel more by becoming a channel member. I've always referred you to that. to join the channel, just tap on the join button on this channel. If you tap on the join icon, you would see GMAT 41, the platinum level, the diamond level. The platinum level goes for 2,000 naira Nigerian currency monthly. And then the diamond level goes for 4,000 Nigerian currency monthly. Now, before now, I always say that if you join on the diamond level, send a message to GMAT 41 on this contact on WhatsApp. GMAT 41 has decided to make this open to you all, whether you're on platinum or you're on diamond. If you join platinum, please send a message to GMAT 41 on this contact for further assistance when necessary. Is that okay? All right, guys. Take good care of yourself. Remember, from GMAT 41, your natural intelligence assistant. I'm always here to assist you, to help you develop, all right, the network of your brain, to help you appreciate your natural intelligence. Make use of GMAT 41. Take your studies seriously. Take your lectures at school seriously as well too. I'll be seeing you, friend, tomorrow. Good night. Remember what I told you we're going to deal with? That I'm going to coach you on certain things you can do to help you improve your reading and understanding. And of course, your remembrance. Yes, your remembrance. That's tomorrow by 8 p.m. Like I said, we're going to discuss that briefly within some minutes. If you have questions, you can ask then, and I'll respond to you. I'll be seeing you tomorrow. Good night.